Future logicians. Today we're going to focus on two of the forms of induction particularly. We're going to talk about arguments from analogy and also causal reasoning. So, went too fast there. Here we go. So we're going to reason on what is likely the case. Again, we're focusing on inductions. And when we are assessing inductive reasoning, we assess it as either strong or weak. Strong meaning that if the premises are true, given the reasoning, the conclusion is likely the case. It's cogent if it's a strong induction with all true premises. It's uncogent either it is weak, all weak arguments are uncogent, or it's a strong induction, but it has at least one false premise. So an argument from analogy rests on a purported similarity between two things. They can be objects, processes, states of affairs, meaning how things are in the world. Since these two things have these similarities, it is likely they share a further similarity, and that's the inference. Indicators of analogical reasoning include the words like, is similar to, as compared to, also even is dissimilar to. The form itself is pretty easy to identify. You'll have two different things. We'll call them X and Y. And there'll be points of similarity, ideally many points of similarity drawn. They'll say they share these properties, A, B, C, D. And then I'll mention that one of these things has an additional property, which it is likely that the other one shares as well. So that's the form of the reasoning. Analogical reasoning is simply pervasive in most of our thinking. As this quote puts it, analogy pervades all our thinking, all our everyday speech, and our trivial conclusions, as well as artistic ways of expression and highest scientific achievements. So I'm just going to give you a couple of real life examples of analogical reasoning, so inductions. First, let's just talk about everyday expectations. When you wake up in the morning and you say go to work or go to school, you expect it to unfold in a certain way, and that is based on you assuming that your days are going to be similar to each other. Okay, just like that. If I want to read a book and I don't know what book to read, I might read some book reviews. Or I might look at how many people would recommend it on Amazon. Okay. And the idea behind that is analogical. I'm assuming that these people's experiences and my experience are going to be similar. The inference is that my experience will be similar to all these other people's experience in reading the book. Finally, medical experiments. Okay, when we test on animals or even test on humans, say a brand new drug that's supposed to cure a disease, if it does cure a disease in that sample, the assumption is analogically it will work similarly in the general population. Okay, so we can see how it's just sort of part of our everyday thinking. Good analogical arguments have a certain standard, and this is the standard ideally. The known resemblance is very great. The known difference is very small. And the person, the arguer's knowledge of the subject matter is tolerably extensive. So they know enough to be able to make an argument about that. For example, I would not know enough. I am not trained medically or in research. So I would not know enough to understand the significance of findings or differences for medical experimentation. Okay, versus everybody knows enough for, say, everyday expectation. So here we're going to analyze a Thomas Reid argument. This is a very old reasoning, but it's analogical. And I want you to practice doing certain things when you're analyzing, not assessing yet. Assessing would mean, is this a good or bad argument? First, I want you to look and figure out the basic parts of the argument. So the parts we're looking for is we're trying to figure out what's being compared, what it's being compared to, what the conclusion is, okay? And you're looking for the similarities and if any dissimilarities are mentioned, okay? So I'm going to repeat that. We're trying to figure out what is being compared, okay? What similarities or dissimilarities are there and what the conclusion is. So here we go. Thus, we may observe a very great similitude between this Earth which we inhabit and the other planets, Saturn, Jupiter, Mars, Venus, and Mercury. They all revolve around the sun, as the Earth does, although at different distances and in different periods. They borrow all their light from the sun, as the Earth does. Several of them are known to revolve around their axes like the Earth, and by that means must have a like succession of day and night. Some of them have moons that serve to give them light in the absence of the sun, as our moon does to us. They are all subject to the same law of gravitation as the Earth is. Thus, those plants may, like our Earth, be the habitation of various orders of living creatures. Okay, so if you need to pause and read this or go back and reread this, I'll give you the time to do that on your own. So, analyze, again, we're just going to go through the analysis of it. We want to consider 1, what is being compared, 2, what is the conclusion, 3, specifically in this one, how many instances are being compared to Earth? So how many different things are being compared? How many similar qualities are noted? And what dissimilarities are noted? Now we can start doing the assessing part of analyzing an argument. So to assess it, we were trying to figure out if given the premises, does that mean that the conclusion is likely? What strengthens an argument from analogy includes when there are more instances offered. So more points of comparison create a stronger argument. An analogy is also more probable if the instances cover a variety of the types of things being compared. So not just examples of the thing being compared, but different types of things also being covered. An analogy is strengthened by the number of noted qualities that demonstrate relevant similarities between the objects, events, or states of affairs. What doesn't strengthen? Okay, so first and foremost, irrelevant qualities. Okay. Often these get smuggled in because they're aesthetically appealing. For example, they mention how things look alike when that's not relevant. But we want to be aware and be on the lookout for something irrelevant. Something is relevant if the presence of it does increase the probability of the truth of the conclusion. Relevant dissimilarities weaken arguments. A disanalogy points out the differences, okay? And more probable counter-analogies weaken the arguments. Counter-analogies offer a new competing analogical inference. If you remember when we went over counter-arguments, counter-analogies are a type of counter-argument. And in this type, again, you hold the premises to be true, but you find a way in which the conclusion can be false, okay? And a way that makes more sense if it's a competing analogy than the original analogy. That would be a strong counter analogy. What also weakens analogical reasoning is just making your conclusion extremely specific. The more specific your conclusion is, the harder to make it probably the case. Okay, so now we're going to practice. We're going to imagine Ty is going to buy a new laptop, and he notices that his friend Cam's new MacBook Air has great graphics. Ty concludes that if he buys any MacBook Air, his laptop will get approximately the same quality of picture as Cam's. Now, what we're going to do is we're going to take information cumulatively here. So remember that as I go through these different possibilities, each one is building off the earlier one. So with the information given on the next slide, raise the probability of the conclusion, lower the probability, okay, or neither raise nor lower. So if you're looking at me in the corner, we're going to do thumbs up if it raises, okay, thumbs down if it lowers, and thumbs neutral if it's neither raising nor lowering the probability. Okay, so first and foremost, Ty's laptop will have the same default browser apps and is the same color as Cam's. So this raise, lower, or neither the probability of the conclusion that Ty will, I'm going to go back to the conclusion for a second just to remind you. Ty concludes that if he buys any MacBook Air, his laptop will get approximately the same quality of picture as Cam's. Next, Ty's laptop will have the same graphics settings. 6 people who own the same laptop as Cam's get approximately the same picture quality. 10 people with different graphics settings who all own the same model but from different years get approximately the same graphics quality as Cam's MacBook Air. And finally, Ty changes his conclusion to state that he will get exactly the same picture quality as Cam does. Okay, next one. For this one, Darla is trying to find a company to do an excellent job renovating some rooms in her house. Her neighbor Gilda hired AC Building to renovate, and they did excellent work renovating her kitchen and her dining area. Darla reasons that AC Building will do an equally excellent job on her rooms. Same thing as the last time with the information given on the next slide. Raise the probability, lower the probability, or be neutral to it. Remember to use each assumption cumulatively in information. Here we go. First, suppose that Darla wants to have her kitchen and dining room renovated by AC Building. What if 5 more neighbors used AC Building on their own kitchen and dining area with excellent results? 10 other neighbors used a different company named DE Reno and found that DE Reno did excellent work. 2 more neighbors used AC Building on their kitchens and dining room and said AC Building's renovation was only decent. Darla changes her conclusion to say that AC Building will likely do approximately as excellent a job as for Gilda. One place that reasoning comes in for analogical reasoning is in legal reasoning. There are many different places where this occurs, but the one thing I want to talk about is precedents and common law. So common law refers to laws that are developed by judges through decisions of the court. This is different from legislative law that is enacted by legislature. In this case, it goes by the reasoning that it's fair to treat similar cases the same way on different occasions. See, since each case is unique in structure, okay, we can think of each legal case is somewhat like each blade of grass. It's just specific to the structure, specific to that thing. But we want to treat similar crimes similar ways in order to be fair. So a precedent is the decision of a court that has a special legal significance. Quote, the basic pattern of legal reasoning is reasoning by example, reasoning from case to case. The finding of similarity or difference is the key step in the legal process. So when deciding, let's say we have 2 people arguing different sides for a civil case. Okay, one side might pick a particular precedent and say this is similar to that. Because the conclusion rendered from that precedent would be similar to the one that they want to have rendered for their client. Okay. On the other side, if there's a competing precedent that might influence the decision so that it weighs on the conclusion of the opposite side, then the opposite side will point to similarities to that precedent for that similar conclusion. Okay. So we're going to practice just a little bit on how to do analogical legal reasoning. So I want you to prepare analogical support or arguments from definition in defense of Brown Delivery Company. So the analogical support should be similar to the way that we analyzed the Reid case. I want you to give points of comparison, okay, that favor the conclusion that you are supporting. Okay, but you're also going to do an argument from definition. If you remember what an argument from definition is, it takes, in this case, you'll take a legal definition and you'll apply it to a particular case. So a negligent person is someone who causes an injury to another person and is liable for that person's injuries. Okay. For this argument, you're going to prepare a defense for Brown Delivery Company. Courts have developed the theory of proximate cause to determine the scope of liability. So how far the legal responsibility extends. Proximate cause is an actual cause that is legally sufficient to support liability. Usually, the defendant is held liable when the effect is foreseeable and the harm is a direct result of their actions. Okay, so I'm gonna press a couple of these things before we move on because this legal language is really important to the case at hand. So what we're looking for is negligence. Okay, a negligent person who causes an injury to another is therefore liable, or you can hold them accountable legally for the other person's injuries. Okay, now proximate cause. Proximate, we think about proximate as proximity or nearness, in this case, nearness in time and space, okay? So we want to figure out what is considered the cause, proximately, to determine the scope, how far the legal responsibility extends, So we hold that this is what is responsible, what is legally sufficient to support liability. So that's what you'll be arguing is either for or against proximate cause. And for this case, you're going to be making sure to point out if an effect is foreseeable and if the harm is a direct result of certain actions. Okay, here's the case. Oh, well. Let me finish the setup. The courts have employed the but-for concept of causation. If the defendant had not acted this way and harm would not have occurred, then the defendant is liable. So here we go. Case Paul versus Brown Delivery Company. Darren Paul was driving the work vehicle for Brown Delivery Company. Brown Delivery Company failed to maintain the vehicle. One of the tires popped, causing the vehicle to crash into a guardrail. Paul had a concussion and was being taken by the ambulance to the hospital when the ambulance crashed and Paul broke his knee. The knee injury required surgery. Construct an argument supporting Brown Delivery Company's position that they did not proximately cause the damage to Darren's knee and subsequent surgery and should not be held liable using the following cases as precedent. Okay, and you need to pause and reread this. This is your case. This is what you're going to argue, and you're going to be arguing in favor of Brown Delivery Company. So here are the two cases that are the precedent for this. First, Sucker versus Lane. Okay, so Lane negligently used gasoline to light his barbecue in a strong wind. The flames from the barbecue ignited nearby trees and then spread to 10 houses in the neighborhood, burning them to the ground. The court ruled that Lane was liable for damage to the houses. Second case, Hunt versus Gomez. Hunt was a passenger in a taxi driven by Gomez. Gomez was drunk and negligently let Hunt out at the wrong corner. While Hunt was walking home, a worker dropped a brick from a building that was under construction, injuring Hunt. Hunt sued Gomez for injury resulting from the falling brick. The court ruled in favor of Gomez. Okay. If you want to do this completely on your own right now, I want to give you a second to take the time and write an argument. Again, you are arguing in favor of Brown Delivery Company, and you're going to be saying that it is similar to Hunt versus Gomez, because in that case, the person being sued was not held liable. Okay, that's similar to the conclusion you want to argue. Okay, and you want to argue it's dissimilar to the case of Sacco versus Lane, where Lane was held liable. Okay, match the premise to whether it best supports that Brown Delivery Companies should be held liable, or Brown Delivery Companies should not be held liable. Proximate cause requires but for or necessary causation. Had Brown Delivery Company not failed to maintain the work vehicle, Paul would not have been in the ambulance accident and injured his knee. So which of these two sides does this work for Brown Delivery Company, or does it not work for them? Next one. Brown Delivery's case is similar to Hunt versus Gomez. Both were driving initially, just as Gomez's realm of responsibility causally ended when Hunt left the car. Brown Delivery Company's responsibility ended once Paul left the work vehicle. Again, you're going to be checking to see if this works for Brown Delivery Company or not. If you see those typos on my PowerPoint, so do I. They are distracting me as well. Okay, here we go. Brown Delivery's case is similar to Lane's. Not doing something required for basic maintenance is similar to not considering likely contributing effects of the wind and the nature of the fire before barbecuing. So which side does this support? Finally, proximate cause requires the foreseeability of the effect, and Paul being injured in the ambulance was not foreseeable to Brown Delivery Company. Okay, so that was our section on analogical reasoning. And now we're going to talk briefly about methods of analysis for causation. Causal inferences occur all the time, and we make them almost intuitively. We see things happen in space and time together, and we assume that they're causally connected. Sometimes they are, sometimes they aren't. We always apply the word cause rather to that element in the antecedents which exercises force, and which would tend at all times to produce the same or similar effect to that which under certain conditions it would actually produce. Okay, so this is a very technical definition of what causation is. What we're saying is that causation comes from us inferring about invisible forces at work, okay, and saying of them that given the same situation, this would tend to produce the same effect, okay? Causal statements make claims about these invisible forces, psychological, physical, chemical, biological, et cetera, et cetera. So when we make these claims, we could say something like, the fire went out because of the rain, okay? The because is saying there's a link in causation between the event, the rain, okay, and the event, the fire going out. Unfortunately for us in English, we use the word cause to mean very different states of the world, okay, or the way they're purportedly related. And because we use them this way, we often muddle the distinction between these very different types of causation. So we can use the word causation to mean necessary condition. This means that without the cause, there will be no effect. Okay, so no cause leads to no effect. Sufficient condition, the cause is enough to create the effect. So if the cause exists, then the effect exists. When we use the word the cause, the meaning one and exactly one, this implies that it's both necessary and sufficient to make the effect occur. Okay, so if we have the cause, then we have the effect, and if we have the effect, then we have the cause. Finally, contributing causation. Often we mean contributing causation. The cause raises the likelihood of the effect given certain conditions, but it means neither necessary nor sufficient. It's not enough to bring about the effect, and the lack of it will not force the effect not to occur. Okay, I want you to practice on necessary, sufficient, or both necessary and sufficient, and contributing causation. Okay, so first, tripping over your own feet at an accelerated rate and landing hard on concrete causes broken kneecaps. Applying for financial aid caused Mona to win the scholarship. Hiking a mountain at least 14,000 feet tall causes one to join the 14er club. Cow burps in Australia cause climate change. Okay, again, sufficient, necessary, both necessary and sufficient, or contributing. Breaking eggs causes an omelet. Hiking a plane from Miami to Bolivia, hijacking a plane from Miami to Bolivia causes one to have flown in an aircraft. Finally, drinking milk causes strong bones. Okay. I'm just going to introduce an even larger idea of words that we use for causation that indicate more complex ways that we really think about causality. And the way that I'm going to introduce this is through von Wright's action theory. Okay, so we use the word cause, okay, for very many different things, but we also have ways to explain our concepts of causation that are a little more nuanced. And these are the types of actions. Actions meaning things that a person or an agent does. Okay. So I want you to pay attention to the fact that sometimes this is what an agent does. Okay. That brings about a certain effect, what an agent commits to do. Okay. But sometimes it's also what an agent chooses to omit to do. Okay. So here we go. We could bring it about that P. Okay. So for example, I could create a drawing. If I created a brand new drawing, I brought it about that P. Next, we could do, hold on, I'm trying to look. I had a list here. Where is my list? I'm going to pause for 1 second and get my list out. Thank you about that. Thanks for bearing with me as I make hiccups throughout this lecture. Here we go. So we're on letting it remain not P. Okay. So let's say that you haven't done your homework and you don't do your homework. You're letting it remain the case of not doing the homework. For sustaining P, we can imagine just paying monthly bills. This keeps P in existence. That's what sustaining is. You could let it become not P. So for example, if you choose not to pay your bills, then your lights might go from on to off. That's right, letting it become not the case. You could destroy the state of P. Okay, so I think if I had my drawing, I could rip up my drawing and destroy it. Okay, that is I could keep it the case, but instead I make it not the case. Letting it remain P. Okay, so let's say that I'm envisioning things in my yard I want to change. Okay, and I see where my flowers grow and I let that remain the case. Sustaining not P. Let's say that I have to keep my yard at a certain inch of grass. Okay, so it can't be higher than this certain level. Let's say this level. Okay, so cutting the lawn to keep not 4 inches, that would be an example of sustaining the state of not that tall. Letting it become P, just let's say that, again, I'm envisioning my yard and I allow native plants to grow wildly where I used to have formal plants. So I want you to practice this way of thinking. Actions can either be omissions, letting it remain the case, or commissions, bringing it about that. Characterize which each type of the following is. 1, leaving your dishes in the sink unwashed. So is that committing an act or is that omitting an act? Watering your plant so it doesn't die. Keeping your friend from knowing some gossip about them. Putting a cup over a candle to extinguish its fire. When we're assessing causal inferences, for contributing causation, we're looking for correlation between cause and effect or between 2 coexisting processes. A correlation is a relationship between 2 or more things, events, processes, or states of affairs. For some event or condition to cause another event, the causing event must precede the caused event temporally. There must be some relation of proximity between the events. Okay, proximity meaning, again, in closeness in time and space. The greater the time and space between the 2 events, the greater the possibility that the other intervening events contributed causally. Again, when you're assessing causation, ideally, we're looking for a set of necessary conditions in combination sufficient to cause the effect. So all that are necessary and together sufficient to produce the effect. It's really important that we consider other reasonable alternatives and rule them out. So we're going to go through Mill's methods. The first method is the method of agreement. The causative event is the phenomenon or circumstance that's common to all the cases in which the event occurs. This is what establishes necessary condition or necessary causation. Without this, there would be no effect. Okay, so here we go. We're going to look at this case where Aziz, Charles, and Carson all ate at the same restaurant. Okay, and they all got sick. So the question is, what is it that made them sick? And if we look, the only thing that they all ate was lasagna. So it must have been the lasagna in the sense of necessary condition. Method of difference is next. For this one, what we're looking for is a case of difference. Okay, we only need 2 things, really, a case where one thing is positive and one thing is negative. And so we're going to look at the conclusion, did the person get sick or not? We want to compare the case where the person did not get sick, in particular to cases where they did. Okay, this will establish sufficient causation. So on this case, we look at the last part and is the person sick or not? Aziz is not sick. Everyone else is. The only thing that he failed to eat that they both ate was pie. Therefore, pie is the sufficient causation. It was enough that they ate that to get sick. So the joint method of agreement and difference, this identifies what commonalities the case shares and what differences distinguish this. It establishes the conditions which are both necessary and sufficient. So now I want you to practice on your own. True or false? The cause of illness in Aziz and Charles is salad. Okay, so you'll have to look at the chart. If you need to pause, you can look at the chart and figure out on your own. Next is a method of concomitant variation. Concomitant meaning together it commits or together acts, and variation meaning changes. So we're looking for both things occurring over the same period of time, okay, and talk about changes, okay? So the method of concomitant variation holds that when variations in particular phenomena coincide with variations in other phenomena, then perhaps there is a causal relation between the two. As Hurley notes in his Intro to Logic textbook, which you might have noticed I love to borrow from, this is how the scientific community established the existence of causal connections between smoking and lung cancer, nuclear radiation and leukemia, and alcohol consumption and cirrhosis of the liver. For the method of concomitant variation, look for words that mean concomitant, same space and time, over the same period. Also variations, look for percentages, mappings, graphs, words that mean change. Last one is the method of residues. This is the one in which you eliminate all known contributing causal relations, and what is left over, what is the residue, can be accounted for by the remaining known contributing causes. For this one, look for words that indicate subtraction or addition, elimination, percentages, or what means residue or leftover amount. Here's an example. Since only 3 things cause HIV, and one knows what percentage is accounted for by needle use, 65%, and unsafe sex, 25%, then one can conclude that the remaining cases, the residual cases, are caused by blood transfusions. So those are Mill's methods. Those are ways to analyze causal inference. I want you to consider this and tell me which type of method was used here and what type of causation is this. Mason and his twin enrolled in a study. They live together, have approximately the same muscle mass, eat the same meals, participate in the same level of exercise. Noah was asked to enjoy the same diet as Mason, but add protein shakes to his diet. Mason was asked to keep the same diet. After 12 weeks, Noah gained 6% more muscle mass. Mason did not change muscle mass. The study used this evidence to help argue that regular consumption of protein shakes causes muscle mass gain. So which of Mill's methods did the study use, and what type of causation is this? Next active learning exercise. When Keith was looking at the $1,000 in contributions to his nonprofit, he found that members contributed 92% and new members accounted for 3%, which left 5% unaccounted for. Keith reasoned that since the remaining amount could only come from non-members, he surmised non-members donating brought about the increased $50. Which of Mill's method was used by Keith? I should say $500. Sorry, which of Mill's methods was used by Keith? So for this, hopefully you have met all these objectives. You can define, identify, assess using logical criteria, and construct good arguments by analogy. You can identify whether an assumption in analogical reasoning raises, lowers, or neither raises nor lowers the likelihood of the conclusion. You can define and create disanalogies and counter-analogies, define, identify, and assess using logical criteria causal inferences, identifying different types of causation, and apply Mill's methods to determine likely causal force and types of causation.